Number 3 on the test is using z-scores to compare two averages. And this is used when two things are on a different scale because z-score will tell you how good they are relative to each other. And it'll make them on the same scale where you can actually compare the two. And let me show you this. So we're going to use the same formulas we used for z-score earlier on number 1. So you need to write these z-scores. Pause the video if you need to, but you could just copy these from number 1. Remember, the z-score is the observed value minus the mean over the standard deviation. All right. So the thing about this problem is we have two different mean, standard deviations, and observed values, and we're going to compare them. So the total points earned in a semester exam by students in the class normal vary with a mean of 675 and a standard deviation of 50. And then there's another class that uses a 0 to 100 scale, so it's tests that use two different scales. So the only way to compare the two is to kind of get them in the same relative number, which is what you use z-scores for, to be able to compare two things relative to each other. So Jessica earns 729 in the first class. So let's fill out Jessica. Jessica got 729. So the observed value for Jessica, xj, is 729. Now, what was the scale of hers? It varies normally with a mean of 675. The mean is 675 on that first one. Because, see, she took the first test. And the standard deviation is 50. Now, Anna, on the other hand, scored a 90 in that second class. And in the second class, used a 100-point scale, right? And it had a mean of 82. So the mean was 82, and Jessica scored a 90. And it had a standard deviation of 6. See, there's 6 right there. So standard deviation of Anna's test was a 6. So you just set these up, and then you get the z-scores for both. And the one that has a higher positive z-score, or just the bigger number in general, a lower negative z-score, would be the better score, right? Which that would be the student that did better. So Anna, if we plug in the formula, it's going to be z is equal to 90 minus 82 over 6. So that is 8 over 6. So that would be equal to 1.333 repeating. So Anna, z-score is 1.33 standard deviations above the mean. Now the z-score for Jessica is going to be 729. See, it's x minus mu over sigma. 729 minus 675 over 50. And we're going to need a calculator for that one. 729 minus 675 over 50. So it'll be 729 minus 675 over 50. And that is 1.08 is what I got. 1.08. So Jessica's z-score is 1.08. So that means that Anna scored 1.33 standard deviations above the mean, and Jessica scored 1.08 standard deviations above the mean. And so our conclusion here would be that Anna actually scored better relative to her test than Jessica did. So Anna has a higher z-score. So she scored relatively higher than Jessica. So yeah, that would be my final answer. Anna had the higher z-score relative to Jessica.